Question number 22, a straightforward simple question from center of mass, and we need to calculate the location of center of mass of this given arrangement, and the arrangement is a rod and bent asymmetrically in this given way. You could see that this length is 2L, this length is L, and this length is L. So for this given arrangement of the rod, we need to locate the position of the center of mass, and the option demands we calculate the position vector in the form of I cap, j cap, or x cap, y cap. It's equivalently the same. Fine. So let's call M1, M2, M3 as the masses. Well, though the geometry is asymmetrical, but the density of the bar is uniform, right? So let me call lambda as the linear mass density, and that is going to be equals to lambda into 2L, or here that will be capital L because the length has been written in capital L format, and the position vector of the center of mass, so R1 vector, the center of mass lies there, so that's L x cap plus L y cap. That's fine. L I cap plus L j cap, and I cap j cap can be synonymously replaced by x cap and y cap. That's all same. Now let's go for this particular portion. So if I see for this, we'll call as M2, and likewise let's find M2 is lambda multiplied by L, and the location of the center of mass in terms of position vector would be 2L x cap plus L by 2 y cap. That's how it goes. 2L x cap L by 2 y cap. And then eventually the third segment is this. And M3 will also have the same mass as M2, and that's lambda times L. What about the position vector of its center of mass? 2L plus additional L by 2. So R3 will have 5L by 2 x cap as the position vector of the center of mass. There you go. You've now M1, M2, M3 and their respective position vectors of the center of mass. And if you want to calculate RCM, so that's all M1 R1 plus M2 R2, in that way it goes, divided by M1 plus M2, here we go till M3. So you just put all those values and solve. You're going to get third option as the correct option for question number 22. Fine, now it's time to move for question number 23. 23rd question, straightforward question from kinetic theory of gas, and here it is. An ideal gas occupies a volume of 2 meter cube at a pressure of 3 megapascal, and we need to calculate the energy of the entire gas sample. So here you need to understand the nature of the gas is not given, whether it's mono, di or poly, but in that case we give the preference to monoatomic. So the energy is going to be 3 by 2 nRT, and this will be 3 by 2 times PV. There you go. You have pressure, you have volume, you put the value, and it's a simple calculation, and you get as 9 into 10 raised to the power 6 joule. So second option is the correct option for question number 23. Let's move to question number 24. Okay, question number 24 may seem a bit lengthy, but it's quite easy, provided you know that basic clue. So here it says, a satellite of mass m is in circular orbit of radius r about the center. A meteorite of the same mass falling towards the earth collides with satellite completely inelastically, and the speed of the satellite and meteorite are the same. Of course, the speed just before the collision. We need to comment on the subsequent motion of that combination, the satellite and meteorite. Let's see. So here is the, circular orbit let me take. Here's the Earth. Now initially the satellite is moving in this direction with a speed v. The meteorite comes in this direction and that is also coming with a speed v. Now say conservation of linear momentum, you can easily calculate what would be the resultant speed, and yes, the resultant speed of course would be in this given direction. Now let's try to calculate how much would that resultant speed be. Use conservation of linear momentum and you would easily find that the speed would be less than the orbital speed. So if the speed at a given distance is lesser than orbital speed, so quite obviously the path would be elliptical and that combined unit would still revolve around the Earth. So option number 3 is going to be the correct one. Let's now move to the next question.